Lecture number 18, component of a nuclear power plants. So far we have studied about the nuclear energy and different aspect of nuclear energy, and we have already studied about the nuclear fission and fusion process as well. We have studied the physics behind the nuclear fission and fusion. Uh, but as we have discussed in our introductory lecture, the main aim of these lecture were to produce some electricity out of nuclear power plants or electricity out of this nuclear components. So now in this lecture, we will be studying about the different components of the nuclear power plants. Normally, the nuclear power plants are situated or located far from the populated area. The power station can produce large amount of electric energy. In some countries, like for example in France, the nuclear power station are actually acting as a base load for base load operation. That means like it is actually producing around like 75% plus nuclear electricity from the nuclear energy. While in different countries, like for example the United States, the nuclear proportion in electricity is around like 20%. Uh, the main operation of the nuclear power plants or the nuclear energy is the element what we call it as a uranium 235 or thorium 233. These nuclear elements, they are subjected to nuclear fission, and when they are actually bombarded, they produce large amount of heat energy. These large amount of heat energy is actually used to produce steam at a high pressure and temperature, and then this steam is actually used to run a turbine, and this convert the energy into a mechanical energy. The turbine drive the alternator, which convert the mechanical energy into an electrical energy. So this is some advantages and disadvantages of the nuclear energy. The nuclear amount of, as we have discussed, the nuclear energy as proportionate was 1 to 3 million ton of coal. So we need small amount of fuel in nuclear power plants. Power plant require less space, obviously. Then we have got low running charges. If we are using it for the bulk electricity generation, definitely it become economical. We do have large amount of deposits, and as we said, like 1 ton would be used for a whole year. So that means like uh, that's quite less energy, less amount of fuel that would be needed. We do have like reliability of operation, not like renewable energy, which has got much less reliability than the nuclear power plants. Does not require large quantity of air for large quantity of water for cooling. But they have got certain disadvantages. Like, for example, fuel is expensive and hard to recover. The capital cost is very much high. Even like, if I would say, like, looking at the technology, if the technology is not transferred properly, like civil nuclear technology is not transferred, so it become more and more expensive. Erection and commissioning of the plant required great technical knowledge. Yes, there is actually one of the reasons, that one of the major disadvantages, and that is like fission brought byproduct are generally radioactive and may cause nuclear pollution. Maintenance cost is very much high, not suitable for the varying load, as a reactor does not respond to fluctuation. Once you have started, it does not actually work in a part load, so you have to run it in a full load. Despite of a nuclear byproduct, it is difficult and disposal of a nuclear byproduct is difficult and problematic, and we do have like very huge amount of nuclear waste which actually is lying around, and that's what actually is a big problem. So future generation will want to depend more on this type of electricity generation power station. and other renewable energy sources due to fast increasing depletion of the coal of the fuel that is in coal, that's in term of a natural gas as well. There are a number of construction projects currently underway, and obviously the most, as I've already discussed, the most of them are either in Chinese or either in India, Pakistan, Bangladesh, and so on and so forth. So we do have like a huge amount of power plants currently installed. So normally the power station does have got different cycles. If I would say like we do have like a nuclear cycle running over here, and we do have like a steam cycle running over here, and we do have like a water cycle running over here. So normally what would happen then? Like steam would be there would be actually a nuclear reactor, and in nuclear reactor we do have like a fuel rods, we do have like a control rod, we do have like moderators, which are essential part of a nuclear reactor. This nuclear reactor produces a huge amount of um, energy in terms of heat. This heat is actually taken out. It is actually a boiler water reactor, BWR. So it is having a huge amount of heat, and this amount of heat is actually recirculated and recirculated in. It is attached to a heat exchanger, or what we call it as a steam generator. In this process, the steam is generated in a steam generator over here, and this steam, when it is actually superheated steam is actually formed, this steam is directed to a steam turbines, a high pressure turbine, and obviously then a low pressure turbine. Then once it is actually circulated in a turbine, it is condensed, pumped back to the steam generator, and obviously so on and so forth. Um, I may like suggest like there is actually a few videos around like YouTube which actually show the different parts of a nuclear reactor. I would suggest like you should actually go through that videos as well. There are different constituents on nuclear power station, and we do have like different components of a nuclear power plants. Um, the location of a nuclear power station and where the nuclear power plant should be located, and we do have like some influencing factor around it. Availability of water, there should be sufficient water must be available for the cooling. The plant must be situated near a river or by seaside. Chashma nuclear power plants, it is actually located near Chashma. The Karachi nuclear power plant, it is situated, or and in the new get an installed nuclear power plant, it is situated at near the Arabian Sea. So obviously the availability of the water should be there. It is also for the cooling purposes, and it's also for the safety purposes as well. That was in Fukushima Daiichi as well. Disposal of waste produced is generally reactive and thus must be disposed of properly to avoid health hazard. Waste must be disposed in a deep trench on a sea away from the shore. Now, normally, this method, sea away from the shore, is normally employed nowadays. Distant from the populated area of let's say, for example, if there is actually something happen in a nuclear power plant, so it should not damage the populated area. So it must be far away from the populated area, and there may be as there may be radioactive particles in the atmosphere, and there may be radioactivity in the atmosphere as well. um, However, like the radioactivity released by nuclear power plant is sufficient less than that is similarly coal power plant. Yes, unless and until there is a disaster, obviously, the radioactivity by the nuclear power plant or the waste or the pollution by the nuclear power plant is much less than the pollution by the coal power plants. Transportation facility site must be accessible by rail or roads and ease transportation equipment and machinery. So that's what actually a little bit of the influencing factor that is needed for the installation of the nuclear power plants or nuclear power station. There are some engineering consideration in the nuclear power plants. For example, the fuel consumption. So the major fuel in a nuclear power plants are actually uranium. So form of uranium that are powered by nuclear fuel are actually uranium metal alloy, ceramic uranium dioxide, uranium carbide, uranium silicate. So these are actually the nuclear fuel for the nuclear power plant. So fission fragment are result of a fission. Some fragments are neutron absorber. Let's say, for example, if we have got a fission taking place in a nuclear reactor, uh, there would be actually a byproduct from the nuclear fission. Some of the byproducts of the nuclear fission process, they are actually neutron absorber. What it say like, it will absorb the neutron and it will be converted to one form of isotope to another. So if there are too many factors existing in the nuclear fuel, so that means like we do not have got much flesh left in the nuclear fuel. So we need to actually compensate. Oh, sorry, if we need to actually install a new fresh fuel into a nuclear reactor, and obviously replace with a new or less burn fuel. This is actually core one of the view of the nuclear fuel. So we do have a nuclear fuel meat over here, which would be somewhere in a form of these material or uranium and different form of uranium. We do have like cladding of outside cladding, zirconium and other form of cladding. Um, then we do have like a fast neutron flow. We do have a coolant, and we do have got thermal neutron flow as well. Um, what should be the property of a nuclear fuel? It should be of low cost, obviously not so low cost, like it should be of a low cost. Good neutron economy, like neutron economy, it should produce neutron and it should actually bombard with a neutron. Good corrosion resistant to a coolant, should not be corroded easily with the coolant, which is actually outside the nuclear fuel over here. Should be physically stable under effect of irradiation, temperature, and pressure. Because if it is actually under a high temperature and a high pressure, so it should not be actually, or it should be actually physically stable. Then with the nuclear fuel, we do have got another component. We call it a reaction coolant. Reactor and coolant transfer the thermal energy and keep the fuel from overheating. Most of the reactor use water as both coolant and moderator. So that's what actually we say like the coolant is actually around the nuclear power plants over here, and these are the material, or these are the substance which take away heat from the nuclear fuel or nuclear rod to the steam or to the water, which actually would be converted to steam. So coolant transfer thermal energy and keep the fuel from overheating. So, and obviously the main reactor fuel, or sorry, coolant is water. The other type of coolant is carbon dioxide gas. Helium is actually quite useful or quite used as a reactant coolant. Ordinary water is there, heavy water is there, organic fuel is there, and liquid metal is there. Um, Desirable property of the reactant coolant should be it should not obviously absorb the neutron, because if it is absorbing neutron, it would be slowing down the nuclear fission process. It should have high heat capacity, so it should take the large amount of heat from the nuclear fuel towards the water for steam generation. It should have got good heat transfer property as well. It should have low neutron activation, not easily activated by the neutron. It should have low operating pressure required to at a high operating temperature. Non-corrosive fuel cladding and coolant. It should not actually corrode the fuel cladding or cooling system, which actually over here. It should have be at low cost. Then we do have got a moderator or reflector. The The moderators slow neutron down so they are available for the fission. Some of these use heavy water as a moderator. Some use graphite as a moderator. The purpose of the moderator or reflector is to reflect as a mirror some of the escaping neutron back into the core area where they become available for induced fission. Water serves this function in most of the reactor design. The alternative power reactor or power reactor moderator is graphite, ordinary water, and heavy water. Desirable property should be high moderating efficiency, low neutron absorption, freedom from damage, radiation, corrosion, and obviously the low cost. Raw materials should be there, manufacturing and installation should be easy. The major component of the reactor, nuclear reactor, or one of the major component is also the control rod. So what control rod do actually? Control rod is controlling the reaction of in a reactor as well. Sorry, in a reactor. So once you actually insert the control rod in a nuclear reactor, so we do have like a nuclear fuel rods. Nuclear fuel rods are actually bombarded with a neutron, and when it is bombarded with a neutron, they are producing heat and they are releasing amount of releasing heat uh, to a coolant. But if you want to control the nuclear reaction, we do have a nuclear control rods. These controls are rods are neutron absorber. They are mostly they are in major they are absorbing the neutron from the nuclear reactor. So once it is inserted fully, it will be absorbing the most of the neutron, and once the neutron is absorbed, the reaction will stop. So that means like it is actually a control rod which is controlling the nuclear reaction, and the neutron is not available for further fission process. We do have like other poisons installed in the nuclear reactor as well. So depending on the condition, depending on the requirement, we do have like different size of reactor size and different shapes of the reactor. Cylindrical shape, large. Have got surface area, volume, large surface area and volume. Reactor size is based on desired power level and output, and safety consideration as well. So you can check different thing on a YouTube. There are different nuclear power plants around the internet. They are open now, so that you can check different pictures of a nuclear power plant. I've already suggested few of the YouTube videos which I would be posting in a Google Classroom. So if you may have got time, you can just check those videos as well. I hope you will understand a little bit of the nuclear power plants as well. If you do have got a question, you can post in a Google Classroom. Thank you very much. Have a nice day.